All right, and the homework from 17 to 21, these are going to be the ones that are going to use the co-function identities, the fact that these are going to be for complementary angles. Now, what you can do is you can look at your identity sheet. Now, tangent and cotangent are going to be the same for complementary angles. But if you notice, these are switched. Complementary angles, the 90 or the pi halves has to be first, okay? So then you have to use the fact that this has been switched. So we have to change the sign of this, okay? And I'm going to start to use, instead of talking about quadrants and changing signs and things like that, I'm going to start to try and use the identity sheet, okay? So on the identity sheet right here, if you notice, the cotangent of negative theta is the same as the opposite of cotangent of theta. And so if I take this and I switch these and I do a negative pi halves plus theta and I factor out a negative, now notice I have the cotangent of negative theta, and that is equal to the opposite of the cotangent of theta, but in this case we have theta minus pi, okay? Now this perfectly matches the cofunction identity. So if I go and look here, the cotangent of pi halves minus theta is the same as the tangent of theta. So I can replace this with the tangent of theta. The tangent of theta is equal to 1.28. So after all of this work, this is equal to a negative 1.28. Okay? This is what we're going to be doing shortly to prove identities. And so you want to get in the habit of showing your work. Proving an identity, you have to show your work. You have to show every single step. You have to demonstrate it. It's a proof, okay? So you can't just say, yep, that's right, that's what it looks like. You have to show every single step from how you get from A to Z or wherever you're going, okay? So let's look at another one. Again, just like the last one, this isn't pi halves minus x, this is x minus pi halves, so I need to switch this. So I'm going to do the same thing, and I'm going to do the sign of a negative pi halves plus x. All I did was change their order, and then I factor out a negative, and I have pi halves minus x. And if we look at our sheet, okay, the sign of pi halves minus x, or the sign of pi halves minus theta, same thing, doesn't matter if it's an x or a theta, is the same as cosine. The signs are the same. Oh, hang on a second. We have this negative to take care of. Back to here. Sine is just like cotangent, so the negative comes out front. So I'll do that first. So I'll have the negative sine of pi halves minus x. Now I can change this to cosine. So the opposite of cosine of x. Cosine of x was negative 0.75. So I have the opposite of negative 0.75. So after all that, it's equal to a positive 0.75. Okay, one more. And these are all in radians. I just did that. Doesn't matter if it's radians or degrees. I know a lot of you have a tougher time with radians, so it's probably good that I'm doing these all in radians. Okay. So again, if you ever have one where the pi halves is first, it's going to make your life easier. They tend not to make your life easier. So we got to switch it again. So I have the cosine of a negative pi halves plus x. Factor out my negative. And then with cosine, cosine is the same. The cosine of negative theta and the cosine of theta are exactly the same. So this is equivalent to the cosine of pi halves minus x. And the cosine of pi halves minus x is the same as the sine of x and the sine of x is equal to a negative 0.37. So this is also equal to a negative 0.37.